Hello, today we're going to look at scalar and vector projections. All right, so let's have a look at this. Let's change the color. So what is our first question? So we're given vectors A and B, right? And we're asked to find the scalar projection of A on B and the vector projection of A onto B. Okay, so what does it mean? What does scalar projection and vector projection mean? So I think we have it written up here. All right, so let's have a look at this. So we have two vectors, A and B. And we want to find the scalar projection of A onto B. So that's the length of this vector right here. So we take the vector A and we project it. Imagine we shine a light above and we project it down onto the vector B. And the length of this vector right here is this scalar projection. The vector projection is the actual vector in the direction of B. So it's the magnitude of this red vector. Let's get a little nicer. It's the magnitude of this red vector plus the direction of B, and that's where the unit vector B hat comes in. Okay, so that's our, move that, that's our scalar, making a mess here, our scalar projection and our vector projection. All right, so now let's go back to our problem and try and figure these two values out. Okay. All right, so first one, A, scalar projection of A onto B. So it's pretty much just an application of that formula. So A dot B over the magnitude of B. All right, so let's do that. So we know the dot product of two vectors. We got 2 times 1 plus 2 root 3 times 1 over magnitude of B is 1 squared plus 1 squared. We take the square root of that. So what do we have? We have 2 plus 2 root 3 over root 2. That's kind of nice. Can we simplify this? Sure, why not? We can factor out a 2 in the numerator. We have a root 2 in the denominator. We can factor out a root 2 in the numerator. Denominator, we're left with root 2 of 1 plus root 3. Good. That's our scalar projection. So now our vector projection. Let's see what space we have here. So the vector projection is this value here times the unit vector in the direction of B. So we need to find this unit vector. So it's the vector B over the magnitude of B. What's our vector? So we actually calculated the magnitude of B. Let's write our vector B in, our magnitude. Why don't we calculate it again? The square root of 1 squared plus 1 squared. So our unit vector is actually this, or let's write it out. There, that's our unit vector. So let's just scroll over here, finish this question off. Therefore, this vector projection is the magnitude that we found in A times our unit vector. So let's put that in 2, 1 plus root 3, put that in brackets, times this B hat. We have B hat right here. Okay, we'll just plug it all in. I think I forgot a square root. Square root of 2 times 1 plus root 3 times 1 over root 2, running out of space, comma 1 over root 2. Let's clean this up a little bit. We can cancel out some root 2's here, and we're left with 1 plus root 3 times this vector 1, 1. And that's our vector projection of A onto B. Excellent. Okay, so looks like we got a second question here. Let's put okay, number 2. Trouble here. Okay. So given these 3 points, A, B, and C, we're asked to find the vectors A, B, and B, C. And we're asked to calculate the vector projection of A, B on B, C. Okay, so let's start with the first one. Let's use a different color. All right, so part A, let's find the vector A, B. All right, B minus A. So we're just subtracting coordinates. Okay, so 1 minus -2 is 3. 3 minus 1 is 2. 3 minus 4 is -1. There's our first vector. Let's calculate our second vector, C minus B. Okay, -6, 7, 5 minus 1, 3, 3. You got that right? Yes. Okay, -6 minus 1, -7. 7 minus 3 is 4. 5 minus 3 is 2, and that's our vector BC. Okay, now B, calculate the vector projection of AB on BC. So let's start with the scalar projection. So we got AB dot BC over magnitude of BC. All right, so we need to take the dot product of these two vectors. Why don't we plug that in? 3, 2, -1 dot -7, 4, 2. And then the magnitude of BC, square root of -7 squared plus 4 squared plus 2 squared. Okay. And we'll take the dot product in the numerator. We get -21 plus 8 minus 2. In the denominator, we have the square root of 49 plus 16 plus 4. All right, let's do this. Not sure why the eraser is so large. All right, let's do this. On the numerator, what do we have? We have -21 plus 8 minus 2. Not sure why I used a calculator for that. Ends up being a habit. I want to get out of the habit of using calculators. And in the denominator, what do we have? We have 49 plus 16 plus 4. Take the square root of that. Actually, the square root is 69. So I'll just scroll over here and we get -15 over square root of 69, which is 8.3. Okay, if we have a look here. It's going back up, scalar projection. Yeah, no, that looks okay. Okay, so we can leave it like that. So we have two choices. We can either use this as our answer, or we can go a step further and actually write it as a decimal. How exactly present the final answer will depend on your teacher and what they're looking for. So we have two possibilities, an approximate one and an exact one. So now we want the vector projection. So this means we need the unit vector in the direction of BC. So let's do that. So that's the vector BC over the magnitude of BC. Well, we found the magnitude of BC above. That was square root of 69. Our vector BC we calculated above as well, and it's right here. We'll plug that in. Good. All right, so now that we have that, our vector projection is then the scalar projection, which was -15 over square root of 69 times our unit vector, -7, 4, 2 over square root of 69. Well, this is handy. the square root of 69s, we can multiply them together. We actually get negative 15 over 69 times this vector, negative 7, 4, 2. Maybe in this case, it's better not to use an approximation for the scalar projection and just go with the negative 15 over 69 because it simplifies quite nicely. Good. Okay, so that brings us to the end of our session today. If you have any questions, send us a note at info@raisebymarks.com or give us a call day or evening and we'll be happy to help you. Thank you for watching and we'll see you soon.